solving linear equations and inequalities. Our objective is to solve linear equations using a variety of methods, as well as solve linear inequalities. Who uses this? Hot air balloonists can use linear equations to calculate the average speed needed to set a world record. Let's start with some vocabulary. An equation is a mathematical statement that two expressions are equivalent. The solution set of an equation is the value or values of the variable that make the equation true. A linear equation in one variable can be written in the form ax equals b, where a and b are constants and a is not equal to 0. An identity is an equation that is true for all values, and a contradiction is an equation with no solution. An inequality is a statement that compares two expressions by using the symbols less than, greater than, less than or equal to, greater than or equal to, or not equal to. Let's start with some properties. For addition, whatever you add to one side of the equation, you must add to the other, so that way you're following the property of addition. Because if you add the same quantity to both sides of an equation, the equation will still be true. But you need to make sure you add the same quantity to both sides. Just like with subtraction. If you subtract the same quantity from both sides of the equation, then the equation will still be true. If you multiply both sides of the equation by the same number or same quantity, the equation will still be true. And division. If you divide both sides of the equation by the same non-zero quantity, the equation will still be true. So, moral of the story, whatever you do to one side, you must do to the other, so that way the two sides stay equal, hence the equal sign. Alright, so let's look at a travel application. Steve Fawcett set a 24-hour hot air balloon record of 3,186.8 miles on July 1st, 2002. Suppose a balloonist has traveled 1,239 miles in 10.5 hours. What speed would the balloonist need to average during the remaining 13.5 hours to tie the record? Alright, well, let's look at this model. We have the distance already traveled plus the average speed times however much time you have left. So time remaining in hours. That's going to equal your total distance. So the distance already traveled is 1,239 miles. And we're going to add an average speed. We don't know what the average speed is. That's what we're trying to find. Then we're going to multiply that by the time remaining in hours. So what was remaining was our 13.5 hours. And we need to tie the distance. So to tie the distance, it's 3,186.8 miles. That's what we're trying to get to. So let's start by solving. Well, we can subtract 1,239 from both sides of our equation. And when we do so, we end up with v times 13.5. You could also have 13.5v equals, let's see, 1,947.8. And since we want to get v by itself, we can divide both sides by 13.5. And we're only left with a v on the left-hand side. And on the right-hand side, when we divide, that's actually going to be about. So we need to make sure we use the about symbol here. And we end up with about 144.3. So the balloonist must average 144.3 miles per hour for the remaining 13.5 hours. Not so sure that's all that possible. But, never know. Let's look at solving equations with the distributive property. So there are two ways we can go about this. For method 1, we can look at the quantity y minus 7 and notice that it's being multiplied by 5. So since this is like one thing, we can just divide by 5 on both sides. So that way all we're left with is this y minus 7. So let's write that out. So in this case we can divide by 5 first, because this is one quantity here and it's being multiplied. So then you're left with y minus 7 equals 5. And to get y by itself, we're going to add 7 to both sides of our equation. And we end up with y equals 12. Alright, so what about method 2? For method 2, we are going to distribute first. So we have 5 times y minus 7 equals 25. And we can distribute first. So we're left with 5y minus 35 equals 25. And then to get y by itself, we're going to add 35 to both sides. That's a 5. And we end up with 5y equals 60. And then divide both sides by 5. We end up with y equals 12. Either way, you're going to end up with the answer for y or the answer for the missing variable. So you can either divide by the 5 first, or you can distribute. Now, to be able to do method 1, you have to only have one number outside the parentheses. You can't have like 3 minus 5 times this quantity. So it has to be on its own for you to be able to do this. Let's try solving equations with variables on both sides now. So it might be helpful to start by knowing which side is on each side of our equation. And then it might be beneficial to start combining like terms and make this look a little bit nicer. So to make it look a little nicer, we're going to combine our 21 and our 7, giving us 28. So we have 6y plus 28 equals, and on the right hand side we can combine our 4y and our 5y to get 9y minus 20. We want to get y by itself. So we can start with getting y on one side of the equation. And to do so, we're going to subtract 6y from both sides. And we're only left with a 28 on the left. And then 9 minus 6 gives us 3y. And keep the minus 20. Alright, well, we're on our way. We've only got one variable now. So let's add 20 to both sides. So we have 48 equals 3y. And then we can divide by 3, leaving us with y equals 16. Alright, so let's keep going. Let's try identifying identities and contradictions. Now, if you recall back to the definition, an identity is an equation that is true for all values. So it doesn't matter what you stick in there, it's going to be true. And a contradiction is an equation with no solution. So nothing that you stick in there is going to work. Alright, so let's start by simplifying these down. So on this side we can combine like terms, and we have 3x and 4x, which give us 7x plus 5. And then on this side we have 7x plus 5. Notice how on the left-hand side and the right-hand side of this equation, they are exactly the same. They have to be exactly the same, meaning this is a positive 5, a positive 5, a positive 7x, and a positive 7x. As soon as one of them is different than the other, you can keep going. So, we know that this has infinitely many solutions, so therefore it's going to be an identity. Alright, now let's try B. So let's simplify the left-hand side first. So we have 8y plus 56 equals, and on this side we can combine like terms. We have 6y and 2y giving us 8y, and then minus 8. Okay, so let's start by getting our y's together. So we can subtract 8y from the left and subtract 8y from the right, and we're left with 56 equals negative 8. Well, wait, that doesn't make any sense. The variables are gone, and 56 does not equal negative 8. This means there's no solutions, so it's a contradiction. It does not work. Alright, so now let's look at multiplying and dividing by negative numbers, which will help us with inequalities. So, to solve an inequality, you basically do the same exact things that you were just doing for an equation. There's only one thing you've got to keep in mind, and that's when multiplying and dividing by a negative number. So if you're multiplying or dividing by a negative number, then that's the only time you actually have this little bit of extra work, because it's an inequality. So if you multiply both sides of an inequality by the same negative quantity and reverse the inequality symbol, then the inequality will be true. So whenever you multiply or divide by a negative, you have to flip this little inequality sign right here. Notice how they flipped it. So you started with 4 is less than 6, and as soon as we did 4 times negative 2 and then did 6 times negative 2, you end up with negative 8 and negative 12. So for this statement in the middle to be true, you would need to know that the symbol needs to flip as well, because otherwise you end up with a non-true statement. Same with if you're dividing. If you're dividing by a negative, notice how it doesn't mean that there's a negative 4 or something like that. You're dividing by the negative or multiplying by the negative. That's when you flip your sign. So let's practice. So solve and graph 9x plus 4 is less than 12x minus 11. So let's start with subtracting 12x on both sides. Generally speaking, I would usually subtract the 9x because I try to make sure that I'm never dividing by a negative when at all possible. But so that this way you can see what's going on, we're going to do it this way. So we have 9 minus 12x, which leaves us with negative 3x, plus 4, which is less than negative 11. We can now subtract 4 from both sides. Notice how everything we're doing is still the same as we normally would, even if that was an equal sign instead of an inequality. And now comes this part that's different. So we're going to divide the left and the right by a negative number. So if we're dividing by a negative, we have x is less than, greater than. So we have to flip the inequality. I meant to flip it on us. So we have x is greater than, and then we have negative 15 divided by a negative 3, which leaves us with a positive 5. So once again, whenever you multiply or divide by a negative number and you're dealing with an inequality, we must flip the sign.